Hi everyone, Miss Grace here. Welcome back. Today we are going to learn how to calculate or how to get the greatest common factor between two or more numbers. The first thing we need to know about what the greatest common factor is that it's essentially the largest number or the largest common number or common factor that will divide evenly into two or more numbers, okay? So that's not going to make a whole bunch of sense right now, but when we start to do examples, it will. So let's actually do a quick example now before I show you how to do it with the prime factorization. So if I take 20 and 12, I'm going to list out all of each of their factors. And remember, though, factors are numbers that can divide into that number. So if I think about 20, well, I know that 1 can divide evenly into 20. 2 can also divide evenly into 20. 3 can't. 4 can divide evenly into 20, so can 5. 10 can also divide evenly into 20. 6, 7, 8, and 9 cannot. And then we also know that 20 will divide evenly into 20. Then I'm going to take 12. Well, we know that 1 evenly divides into 12. 2 also divides evenly into 12. 3 as well will divide evenly into 12, and so will 4. 5 can't. 6 can divide evenly into 12. And then our last number is 12 itself. So we have to find the biggest common factor between these two numbers. So 2 is common, but it's not the largest one. Our largest common one would be 4. So that's your greatest common factor, 4, between 20 and 12. However, sometimes we're going to get really large numbers and you're not going to want to write out all their possible factors. So there has to be an easier way to do these types of problems. And we can figure out the greatest common factor of larger numbers or even of just 20 and 12 by using our method of prime factorization, or what we call our hockey stick method. So this is what we're going to mainly focus on, is using our prime factorization or our hockey stick method. Okay, so step 1, first thing you need to do in order to calculate your GCF is you want to do your hockey stick method. Our second step is that, hockey stick method for first one, just a reminder. Second step, you want to use any common factors between those 2 or 3 numbers. So use only common factors between those 2 or 3 numbers, and you want to take the lowest possible exponent on those common factors. Okay, so take the common factors between the numbers and the lowest exponent. Once again, if it doesn't make a whole bunch of sense now, totally fine. It will once we start to do an example. In step 3, all you have to do is multiply them together if you have multiple common factors. Okay, let's do an example. We have 16 and 36. So step 1 of finding my greatest common factor is I need to do my hockey stick method for both 16 and 36. So I need to do my prime factorization for both numbers. So I'm going to take 16, and my lowest prime number that goes into 16 is 2. So I can start by dividing 16 by 2, and I get 8. Then I'm going to take my 8, and I'm also going to divide that by 2, and I get 4. If you haven't watched my video on this, go back and watch it. We're going to take 4, divide it by 2, and then you get 2. Okay, so now I'm going to take my hockey stick, and I'm going to put a box around all of my prime numbers, and I'm going to list them out. So 16 is equal to 2 times 2 times 2 times 2, or 2 to the power of 4. Okay? Since we have 4 2's, it would just be 2 to the power of 4. Okay, so now I have my prime factorization for number 16 done. Next, I'm going to move on to 36. So I'm going to start by dividing that into that by 2. And I get 18. Then I'm going to take 18 and I'm going to divide it by 2. And I get 9. Then I'm going to take 9, and my lowest prime number that can go into 9 is 3, and that equals 3. So now that I have a prime number here at the end, I know I'm done. I'm going to draw my hockey stick around all my factors, and then I'm going to list them out. So 36 would be equal to 2 times 2 times 3 times 3. Or I can put them together as powers, so the two 2's can go together and the two 3's can go together. So 36 would be equal to 2 to the power of 2 and 3 to the power of 2. So now we've done our prime factorization for both numbers. So my second step now is to find my GCF by taking the common powers between both of these numbers and the lowest possible exponent. Okay? So if I look here between 16 and 36, they have only one factor in common, and that's mainly because 16 only has 1. They both have 2 as a factor. So that's the only common one they have is the 2. Okay? We also have to look at their exponents. I have to take the one with the lowest possible exponent, which is 2 to the power of 2. Right? We have 2 to the 4, and then we have 2 to the 2. Since 2 to the 2 is smaller, that's the one I choose. So common factors and lowest exponent. Then I just solve for it. 2 to the power of 2 is equal to 4, because that's just 2 times 2. So that would be my GCF between 16 and 36. Okay? We're going to do one more example. We're going to take 138 and 198, and we're going to find the GCF between these two numbers. So similar to our last example, the very first thing you need to do is your prime factorization of both numbers, or our hockey stick method for both numbers. So the first thing I'm going to do is I'm going to take 138, and I'm going to think of the smallest prime number, or any prime number that will go into 138, and that's going to be 2. Let me list them out. Your prime numbers are 2, 3, 5, 7, 11, 13, etc. Try to remember those. But my one that I'm going to divide into 138 is going to be 2. And then you end up getting 69. Then I'm going to take 69 and I'm going to divide that by 3, because that is my lowest prime number that will go into 39. And then 69, sorry. And then I end up getting 23. 23 is actually a prime number because I cannot divide any of those numbers evenly into 23 except for 1 in itself. So because 23 is a prime number, I'm done. I'm going to draw my hockey stick around 3 of these numbers. So my prime factorization for 138 would be 2 times 3 times 23. Okay? I don't have any duplicates, so nothing can be raised to a power, and I just leave it as is. Okay? So my next step now is I need to do the same thing for 198. So I'm going to take 198. The lowest or any prime number that goes in 198 is 2, and then I end up getting 99. Then I'm going to take 99, and I'm going to divide that by 3, because that is the lowest prime number that goes into 3. It goes into 99. If you use 11, that's also fine too. It doesn't matter. You're still going to get the same answer. So I get 33. Then I take 33 and I divide that by 3, or 11, and you would get 11. Okay, so it doesn't matter the order that you do this in, you still will get the same factors. Drawing my hockey stick around all of my prime numbers, and then I'm going to list them out. So 198 is equal to 2 times 3 times 3 times 11. And now I have 2 3's, so I can actually write that as a power. So my final answer for that would be 2 times 3 to the power of 2 times 11. So remember, in order to get my greatest common factor, I need to pick factors that are the same or common between these two numbers. And I actually have two. I have 2 that's common between both and 3 that's common between both. So I'm going to use both of those numbers, but I need to pick the lowest possible power. So 1 is the lowest possible power on a 2, and also 1 is the lowest possible power on the 3 as well, because I have 3 to the power of 1, or 3 squared. Since 3 on its own, or 3 to the power of 1, is smaller, that's the one I'm using. Then my step 3 is just to multiply those factors together. So 2 times 3 is 6, and so that would be my greatest common factor between 138 and 198. And that's it. That's all you have to do. So you just take the common factors and the lowest power on each of those. Thanks for watching.